Alright, so now we are on the third video, and we're going to try a proof of the proposition that any two vertical angles are congruent. And we did a vertical angles question before, but we didn't prove that it's true for all cases. So I'm going to go ahead and do some labeling here. And before we said things like these two would be vertical angles and these two would be vertical angles, and so we're going to go ahead and see if we can prove that. And so I'm going to start out with, since AD, line AD, is a straight angle, and it also goes through B, and it would have to equal 180 degrees, because straight angle equals 180 degrees. So I can write a couple equations here. Can I say that angle ABC is equal to 180 degrees minus angle CBD? So basically what I'm saying, if I add this to the other side, that this angle and this angle added together equals 180, just subtracting that from both sides. And that's true enough. So then let's try another equation. Let's say that angle EBD is equal to 180 minus angle CBD. So I'm saying this angle and this angle are also make a straight angle. So then, since this part is the same, can I say that angle ABC is equal to 180 minus angle CBD, which is also equal to angle EBD? And then chopping out the middle part, can I say that angle ABC is equal to angle EBD? And it is the same, so I've now proven that any angle that's up here and any angle that's down here would be the same measure. Would it be difficult to move to this one and this one? No. Did I use any numbers in here to make it an example instead of using all variables? Well, the only number I used is 180, and that's the measure of a straight angle. So other than that, I didn't use any numbers to make it an example. So that would be a proof. All right, so let's move to section 2.4. And in section 2.4, it talks about lines that do not meet would be parallel. So we have a parallel postulate that says, given any straight line and a point not on the line, there is exactly one straight line that passes through that point that never meets the first line. Okay? Parallel postulate. And for any two lines M and N, there is a transversal, a line that cuts through both of the lines. So in this example, this would be my transversal. Determine the measure of all the angles without measuring directly. So we know that since it's a straight angle here, CHD is a straight angle. So we know that this would have to be 112 to add up to 180. We also just got done proving that vertical angles would be the same measure. So I can put those in there. And if they are parallel, this line, and I'm going to put these little arrows in here to indicate parallelness. That's a shorthand notation for making parallelness. We know that this would be a corresponding angle here 68. This one would be 112. This would be 68. And this would be 112. Because of their parallel, we know that the angles will remain the same on each one. So we have a bunch. We'll see if we can get all of them in here. We know that corresponding angles, and I already used that term, and I'm going to say, let's just for the fun of it, do some numbering here so I can make this a little bit quicker. We know that corresponding angles like AGF, I called it angle 1, and CHG, angle 3, would be corresponding angles. Angle 1 is congruent to angle 3. And there are 3 other pairs of corresponding angles, and I'm going to put them in here. Angle 2 is congruent to angle 4. Angle 8 is congruent to angle 6. Angle 7 is congruent to angle 5. Those are all of the corresponding angles in this picture. Alternate interior angles, I'll use a different color for that one, and they give us one example, that AGH, which I called angle 2, and GHD, which they called angle 6, and there's one more pair of those, and I'm going to write it down as angle 3 is congruent to angle 7 by alternate interior. You see the word alternate in here in a couple of these. Alternate means on the opposite side of. So opposite side interior angles. So 2 and 6, 3 and 7. That's when they say alternate, that's what they're talking about. Okay? Alternate exterior angles. And again, they're giving you a couple examples here. I'm going to go ahead and say angle 1 is congruent to angle 5, and angle 8 is congruent to angle 4. They are alternate exterior angles. And same side interior angles. So they're talking same side interior angles. And we have a couple of those, but this one's a little bit different. All of these were congruent, 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 congruent. Same side interior angles are supplementary. Supplementary means they add up to 180 degrees, so we have 2 pairs of same side interior angles that are supplementary. Angle 2 plus angle 3 equals 180. Angle 6 plus angle 7 equals 180. And the same is true of the same side exterior. I could write angle 1 plus angle 4 equals 180. Angle 5 and angle 8 equals 180. A lot to remember on that one. We may have to go over that during class time. And now we're supposed to just find the rest of these. So if this one is 75 degrees, vertical angles gives me 75 there. Supplementary, because it's a straight line, makes that 105. Vertical angles gives me that. Corresponding angles gives me the 105, 75, 105, 75. Make sure you're able to do that quite quickly, because that's a very common question. All right, so now we have 2 sets of parallel lines, and we're supposed to find out what each of those is. I'm going to say, well, if they're parallel, then we know that this angle over here is 2x plus y plus 15. So we know that these 2 angles would add up to 180 because they are a linear pair. So I'm going to say x plus 2x plus y plus 15 equals 180. Then I'm going to say, well, if this is that, then I'm going to move that up there because those would be corresponding. And if this is also corresponding to that spot, so the chain leads me to believe that 2x plus y plus 15 is equal to 2y. And right now would be a good time to pause so you can solve this without me doing it. And so I simplified both of the equations, and then I just substituted this, or moved this over here to use elimination. And I got that x was equal to 30. So we know that this angle in here is 30 degrees. And so I can substitute back in, so I get 2 times 30 plus y plus 15 equals, and I'm going to just say 150. And where did the 150 come from? Well, these two angles have to be supplementary because it's a linear pair, and so 30 and 150 add up to. So I'm going to say y 60, 75, 60, 75 plus 75 equals 150, and so I get y equals 75. All right, hopefully you got that. There's a little bit of a trick to this one, so I'm going to draw in a line that is parallel to the other two lines. So if it's parallel to the other two lines, you're going to say, well then this here would have to be alternate interior, like we just got done doing, and that would make it 35. And this one would also be alternate interior, so that one would have to be 40. So the measure of this angle in here would be 35 and 40, which gives me a 75-degree angle. I think there's one of those in your homework, so I threw it in here. All right, so now we're going to pause. We're going to stop, and then we're going to start here on the next video.